Welcome to my talk on hacking the JSX pragma for fun and profit. My name is Akash Hamirwasia. I write code at Razorpay. I also love building products on the web, contributing to open source, and learning new technologies. Some of my products include Blaze, Untab, Diode, and more recently Slanted, which you can check it out at slanted.app. You can connect with me on my Twitter, GitHub, or check out my website for various blog posts, past conference talks, and various other projects I've worked on. So let me start my discussion with a brief introduction of what JSX is. I'm sure all of us here would have used JSX, and JSX is simply that HTML-like thing that you write in your JavaScript files to define your UIs. Here's an example JSX snippet, and I've often seen people relate JSX as an exclusive feature in React, but that's not really the case. JSX is supported by React, but it's also supported by other libraries like Preact, Solid, Quick, and even other frameworks like Vue. So the beauty of JSX is that if you look at the code snippet over here, you can't really tell whether I'm using React, Preact, Solid, or Quick. I might be using any one of those, but you don't know just by looking at the JSX code. It's library/framework agnostic. Next, let me discuss what a pragma is. So pragma is a compiler directive that tells the compiler how it should go about handling the contents of a file. Some popular directives include the use strict directive in JavaScript to tell JavaScript to go into strict mode, and a more recent directive is the use client directive that was introduced in Next.js to declare a component as a client component. Now let me explain the relationship between browsers and JSX. Because browsers don't understand JSX, they only understand JavaScript. And compilers actually replace your JSX code with the calls to a special function. And these compilers are tools like Babel, SWC, and TypeScript. So to understand this process better, here's a code snippet, some simple JSX. And if you pass this through a compiler, this is what you get. So it has converted your entire JSX code to calls to these special functions, JSXs and JSX. But notice how the complete context of your JSX code is still retained. Just by looking at the JavaScript snippet at the bottom, you can still tell that there is a container component with a class name bgred, and there are two child elements, h1p. So the transformation process is simply replacing the JSX code with function calls so that browsers can understand it. Some of you might be familiar with this transformation in the form of react.createElement calls. So prior to React 17, there was this classic JSX transform, which used the react.createElement function to replace your JSX code. So same concept, still replacing the JSX code, but this time it's using the react.createElement function instead of the special functions introduced in React 17 and above. So finally, what is JSX pragma? JSX pragma is a directive that tells the compiler which function it should use to make this replacement. So here's a small code snippet. The first line that you see, the comment over there, that actually is the JSX pragma. It tells the compiler that whenever you're transforming this code, instead of calling react.createElement, call my JSX function that I've defined. So if you pass this code through the compiler, this is what you get. Instead of calling react.createElement, it's now calling the my JSX function as I told it to do. And still the transformation is still the same, the context is still there, just the function that it's calling has changed. So looking at this, you might be wondering, well, why do we even need a custom JSX function? To illustrate this example, here's a simple example. I have some React code over here, and there is a div with a class container and a string hello React Nexus. Now, when I add a JSX pragma and my custom JSX function, this is how it looks like. My JSX function is simply console logging all the arguments, and notice at the top right, you don't see any output. In the previous slide, you saw a card with hello React Nexus, now you don't see anything. And that is because the my JSX function that I've defined is not returning anything that React can use to render the UI. But it has a console log. So let's observe the console and see what it outputs. I see this. So the first console log, there is the first argument div, which indicates that the first argument to this my JSX function is the type of the element or the type of the component that is being passed to it. Second is an object of all the props that are passed to this component. And the further arguments are all the children elements that are there or that are passed to this component. So to render something back on the screen, instead of just console logging, we can introduce react.createElement call to return some data that React can use and render on the UI. So I finally see something back on the screen. But notice how this myJSX function that I've defined is now acting as a proxy. I can introduce any code in between, do anything, and eventually I'm still returning some React element that React can render. So when I first looked at this, I was wondering, what if we injected some useful code in there? Code that is repetitive throughout your component in your entire code base. Would it lead to an improved developer experience? So let's look at some examples to answer these questions. So these are some practical examples of certain custom JSX functions that you can use. So I'm sure most of us here would have used Tailwind CSS or some other CSS library and would have encountered this problem of dynamic class binding. Here's a basic example. There's a button component, takes in two props as primary is large, and it interpolates in those props and attaches certain class names dynamically. So I'm generating the string based on the isPrimary and isLarge prop. Now, this looks fine on the slide, but as soon as you introduce more props, this becomes very hard to maintain. You might have nested interpolations, and over many years, you won't even understand what this code is doing. So some of us have previously used a package called class names to solve this problem. Class names package exposes a function called CX, which replaces your class name string with a function call. And here you define all your classes as an object, and class names will automatically include or exclude certain classes based on the conditional that you have. So bgblue 500 text white will only be included if isPrimary is true. Now when I looked at this, I wondered, what if I expose the functionality of class names package throughout my code base? And that is where custom JSX functions come in. So I define my custom JSX function, and to use it, I use the JSX pragma, add JSX myJSX function. And within this myJSX function, I'm again still returning a React element using react.createElement, passing in all the relevant props. And just before return, I introduce this extra check. So if the class name prop is set in my component, pass the value of the class name prop in my CX function. Call that function, and whatever value it returns, store it back in the class name prop. And then go ahead and render the React component. So what is the benefit of doing all this? If we come back to our button component, the developer doesn't have to worry about importing class names, call CX function, or do any of that. They can still use the familiar class name prop, but instead of just using strings or interpolations, they can pass the same structure that class names package use to define their classes declaratively. And this leads to maintainable code and readable code in the long run. So the functionality of class names package everywhere, you don't have to think about any imports, it just works. You can also use custom JSX functions to introduce a new prop in JSX. And this is what Emotion CSS does with its CSS prop. So this is some code from the Emotion CSS repository. They have this JSX function, which is similar to what we have seen in the previous slides. And here, at first, they check whether the CSS prop is set in the current component. If the CSS prop is not set, simply fall back to calling react.createElement and rendering the default component. But if the CSS prop is set, instead of rendering that component, render a special component called emotion and pass in the props from the createEmotion props function call. Now the beauty of this code snippet is all the style generation logic is inside that emotion component and createEmotion props function. But by introducing a custom JSX function, they have exposed this functionality to your entire code base. So anywhere in your code, you don't have to think about importing emotion. You can just use CSS prop and tap into the functionality that Emotion CSS library brings. Now you can do even crazier things, like runtime prop validation, which might be useful in certain scenarios. So here's again another JSX function. And here, what I'm doing is I'm checking whether my component has a Zord schema attached to it. If there is a Zord schema attached to it, simply parse that schema and pass in the props to it to validate whether the props are actually matching the schema that I've defined. If it doesn't match the schema, it'll throw an error. if the validation fails, if it doesn't match the schema. And for the end developer who's using this JSX function, they can use it like this. So I have a profile component, and let's say it takes a user object, which is a very dense object. It can have various fields. Let's say it has name, age. And I want to ensure that whenever this component is rendered, the user prop always follows the same schema or same definition or same structure that I want it to have. So I can attach a schema property on my component and define my Zord schema and tell it that it should have a user prop, which is an object, has name, age, with the relevant types. And when I'm using the component, I can wrap my profile with an error boundary. So for whatever reason, let's say the user data that is sent to this component does not match the schema I have expected it to be, it'll throw an error because Zord validation would fail. And when it throws an error, it'll get caught by that error boundary. And I can use the error boundary to render some helpful text, say that some error happened, or I can pass in that error to my error tracking tools like Sentry to understand why that error happened and go about fixing it. So to summarize, JSX pragmas are used to modify how the compiler treats your JSX code. I like to think of them as global middlewares that surgically update the data React sees before it goes about rendering your UI. Using custom JSX functions can be beneficial because it can allow you to add new capabilities to the existing JSX syntax. It can avoid repetitive or complex code that is there in your code base. And it can improve the overall developer experience. But use it safely because there are some cons to it as well. So because you're modifying something so fundamental like JSX, it might deviate from the natural understanding of what people have about JSX. They might not know what this CSS prop is unless you tell them. They won't know that your class name has changed to follow this new structure unless you tell them. So when you're onboarding new people for your projects, it might be hard to tell them that, okay, we are using a custom JSX function that adds in new capabilities. And it may also add some runtime overheads. So for the runtime prop validation, you will validate those props in every render for that component, which might be slow. So again, you have to decide whether you want to include this in a JSX function or in your build step. With that, I come to the end of this lightning talk. If you have any questions, don't hesitate to reach out. I'll be around in the conference, and I'm eagerly looking to connect with you all. You can connect with me on Twitter, GitHub, and if you are interested in getting the slides, check it out at slides.akashhamirwasia.com. Thank you.